Look at the tire on your car. It spends its life touching the road at high speed, carrying hundreds of kilograms of weight, while absorbing heat, friction, and constant impact. Eventually, the tread wears down, the tire is removed, and most people stop thinking about it. But a worn-out tire isn't simply a useless piece of rubber. Inside, it is a complicated mixture of rubber, reinforcing steel, and textile materials. And when that tire reaches the end of its useful life, an entirely different industrial journey can begin. If you enjoy discovering what happens behind the everyday objects we normally never think twice about, do well to press the like button and subscribe to Material Unknown, because we're about to take one worn-out tire apart and follow the materials hidden inside it. Millions of tires are removed from vehicles every year. Some are collected through established tire management systems. Others can end up in stockpiles or illegal dumping sites. And storing large numbers of discarded tires isn't simply an eyesore. Large tire piles can create serious fire risks and can collect standing water that provides breeding habitat for mosquitoes. That's one reason scrap tire management has become an important industrial and environmental issue. When a scrap tire reaches a processing facility, the first thing that happens isn't melting. It's inspection. Tires can vary enormously in size, construction, and condition. Some may still be suitable for reuse or retreading. Others are too damaged or worn and are sent for material recovery or other forms of beneficial use. For the tires entering a recycling operation, the objective is to recover useful material from a product that was designed to be extremely durable. And this is where the tire begins to lose its identity. Industrial cutting equipment attacks the massive rubber ring. The tire is sliced and reduced into large pieces. The pieces may then pass through increasingly aggressive size reduction equipment. What was once a recognizable tire is becoming a stream of rubber-rich material. But there is something hidden inside that rubber: steel. A modern tire isn't simply rubber. Steel reinforcement is built into the tire's structure. There can also be textile reinforcement, depending on the tire's design. So as the tire is shredded, the processing system has another job: separate the different materials. Magnetic separation can recover ferrous steel from processed tire material. The steel can then become a separate recovered material stream. The tire is being taken apart, material by material. Once much of the reinforcing material has been removed, the remaining rubber can be processed further. Grinding machinery reduces the rubber into smaller particles. The final size depends on the intended application. Some processes produce relatively large rubber pieces. Others produce much finer material known as crumb rubber or ground rubber. And suddenly, something that looked like waste begins to resemble a raw material. This is the fascinating part. The tire is gone, but the rubber hasn't necessarily disappeared. Ground tire rubber can become an ingredient in different products. It can be used in certain molded and extruded products. It can be incorporated into some athletic and recreational surfaces. It can also be used in rubber-modified asphalt and other applications. The exact destination depends on the quality of the recovered material and the market that can use it. One of the most interesting destinations is the road itself. Processed tire rubber can be incorporated into certain asphalt applications, instead of remaining in the tire. Some of that recovered rubber can become part of a pavement material. The tire that once carried a car along a road can, through a completely different industrial pathway, contribute material to the road itself. It's a very different kind of second life. But roads aren't the only destination. Ground rubber can be used in products such as mats, molded components, traffic-related products, and certain recreational surfaces. The important point is that recycling doesn't mean there is one universal destination. The material's next life depends on its properties, how it was processed, and what manufacturers need. A tire can become something that looks nothing like a tire. But there is another major pathway. Not every scrap tire is processed into ground rubber. Some tires are processed into tire-derived fuel, commonly abbreviated as TDF. Instead of recovering the rubber as a material for a new product, the tire's stored chemical energy is recovered through controlled industrial combustion. This is considered energy recovery, not material recycling, and it is used in certain industrial facilities, including some cement kilns and other permitted combustion systems. To produce tire-derived fuel, scrap tires can be shredded or otherwise reduced in size. Depending on the combustion system, some of the reinforcing wire may need to be removed. The resulting tire-derived fuel is still a solid fuel. Its high heating value is one reason it can be used as a supplemental energy source in appropriate industrial processes. But this pathway is fundamentally different from turning a tire into crumb rubber. One recovers material, the other recovers energy. So what have we actually recovered? Rubber, steel, and, depending on the tire textile material and process, what looked like one giant black object was actually a carefully engineered combination of materials. And that's why recycling a tire isn't as simple as throwing it into a machine. The entire process is about separating those materials and finding useful destinations for them. And the scale is enormous. The U.S. Environmental Protection Agency's latest published product-specific data estimates that about 6.53 million tons of vehicle tires were generated in 2018. Its data estimated about 2.61 million tons were recycled, while about 2.71 million tons went to combustion with energy recovery, and about 1.21 million tons went to landfills. These figures are U.S. data and date to 2018, the latest year in that EPA dataset, so they shouldn't be treated as today's global numbers, but they show the scale of the material challenge. Millions of tons of tires have to go somewhere. Now look at the journey. A tire begins as a sophisticated piece of engineering. It carries you thousands of kilometers. Eventually, the tread wears away. The tire is removed. Then industrial machinery cuts it apart. Magnets recover steel. Grinding equipment produces rubber particles. Those particles can become ingredients in new products. Or, through a different pathway, processed tires can become a source of energy. The tire disappears, but its materials continue moving through the industrial system. If you found this journey fascinating, click the like button and subscribe to Material Unknown, because the next time you look at something you were about to throw away, remember, you may only be seeing the end of the product's first life. A tire looks simple from the outside, a black ring of rubber, but underneath that surface is a carefully engineered combination of materials designed to survive one of the harshest environments we encounter every day. And when that tire finally reaches the end of the road, the industrial story doesn't necessarily end. It can be cut, separated, ground, recovered, reused, or used to recover energy. The tire itself may disappear, but the materials inside it can continue. This is Material Unknown. Every object has a story. We uncover what happens next.